Okay, finally able to sit down and get you this lecture for chapter 26, because we finally finished the bacterial diseases. Thank goodness it's over. So now you know it's downhill from this point, because once you kind of get over that hump of the bacterial diseases, the rest of the information is not quite as cumbersome. That's the bulk of it. Um, because the next couple of chapters we only have maybe no more than about six, seven diseases. When we get to the viruses, it might be a few more, but those typically are ones that you've heard of before, so they're not quite as cumbersome as the bacterial diseases. And in chapter 26, we're just focusing on the mycoplasmas, rickettsias, and chlamydias. And it's really not that many of them. I think there's only one mycoplasm that we need to identify, and we'll talk about that. And then with the rickettsial diseases, the rickettsias are the smallest free living obligate intercellular parasites. So they have to have a host in order to live. And then with the chlamydia, that typically should kind of sound familiar to you. So we'll talk about chlamydia trachomatis, and it has three different pathogenicities. Or we'll just identify the certain pathogenicities that you'll need to know for your quiz. So I'd like to thank you very much for earlier today agreeing to be able to allow me to present this as a video lecture to you. So I just tried to make sure I got it to you ASAP so that you would have it available for the entire week. So having said that, let's jump right into it. I have a couple of not so scientific ways of remembering the various rickettsial diseases, because we've got three different types of rickettsias. We've got rickettsia rickettsii, rickettsia prowazekii, and rickettsia typhi. I believe those are the ones that and rickettsia typhi that we're going to identify. So a couple of semesters back, I had the students come up with their own not so scientific ways of trying to remember the rickettsial diseases. So I will present those to you. But what I would like for you to also try to do is to create your own rickettsial, not so scientific way of remembering those different diseases, the differences between the rickettses, because some of them are as a result of biological vectors such as a tick. There are others that are in regard to fleas, and then there's one that's in regard to lice. So you need to have a mechanism by which you remember which one would be associated with the tick, which is associated with the lice, and which is associated with the tick, lice, and fleas. So I'll give you what I have, and then try to come up with at least one by next class to be able to share. And what I might even do is, I think I'm going to do it like that. I'm going to make a blog spot on Blackboard for you where you can put up your not so scientific way of remembering that disease, and post it to the blog spot. Maybe it'll help your classmates. Maybe it'll help you. And in addition to that, maybe it'll be worth a little something to you. What you'll start to notice on your quizzes, and a few of you did get your quiz back from last week, I added 5 additional points. Those 5 points come from you turning in your note cards. If you don't turn in your note cards, you don't get the additional 5 points. You do, you get the 5 points. So if you turned in your note cards today, and after I review them, you can get as much as 5 points added to your quiz. So that's that. All right, so having said that, we're going right into chapter 26. I've got my PowerPoint presentation, I've got any notes that I'm going to take, and I've got my textbook. So hopefully you have those same things as well. Going right to it, starting with the mycoplasms, and the only one that you need to know is Mycoplasma pneumoniae. We've got the general information that comes up on the first slide after mycoplasms, and it talks about the fact that they do not have a cell wall. Well, the lack of a cell wall makes them more difficult to try to kill, because antibiotics, as I've told you before, like to be able to find a receptor site on the cell wall to adhere to in order to be able to use the antibiotic to disrupt the genetic information of the microorganism. But because mycoplasmas don't have a cell wall, there's nothing for it to attach to. And it kind of takes on the shape of a fried egg. That's what I list in the PowerPoint. But what really happens is that these microorganisms kind of have just that cytoplasm, so they kind of follow the path of least resistance. So as a result, if I don't have a cell wall, let's just say this is the cell wall, and this is the antibiotic that needs to attach to it. When the antibiotic gets in contact with it, all the cell wall is going to do is collapse around it. So it can't penetrate it, and it makes it very difficult to kill. So, in addition to that, it talks about the fact that it doesn't stain well with the gram staining. Well, we've already talked about how gram staining works in anyway. It has to adhere to the complex lipids of the cell wall and the polysaccharide chains and all of that in order to have that stain adhere to it. Okay, so the one that we have that you need to know is Mycoplasma pneumoniae. And so this is one that obviously lends itself to what it causes. It causes pneumonia, but it's not bacterial pneumonia. And the thing about it is that this particular type of pneumonia, this is what we refer to as the walking pneumonia. You know, when somebody has pneumonia that has been caused by Streptococcus pneumoniae, they're not up from it the next day. Talk about, yeah, I had pneumonia yesterday, but I'm over it today. No, not with bacterial pneumonia. It doesn't just go away like that. But what they may have had is what we refer to as walking pneumonia that's caused by this mycoplasm. So these are typically contracted in places where there's a high concentration of people. In the military, in the barracks, college dormitories, shelters, other places where you'll find a lot of people in very close contact, and it spreads very rapidly. But it's not as virulent as Streptococcus pneumoniae, but it does have the ability to cause pneumonia in the host. And that's the only one that you need to know. And please also make sure that you have one note card for that one. And that's the only one that you need to know in that category. But when we get to the rickettsial diseases, we've got a few more that we need to know. A little bit of general information about the rickettsial diseases. Well, as I stated earlier, they are the smallest obligate intracellular parasites, which means they must have a host in order to live. They reproduce by binary fission, which is that simple transverse division that we talked about. 1 splits into 2, 2 split into 4, so on and so forth. And they have no mechanisms of locomotion, no flagella, no pili. They don't have capsules to increase their virulence. We know that the pili are not for movement, but they are for conjugation. They don't have that, nor do they have the ability to create endospores. So they are pretty much reliant on wherever the host cell is. All right, so the first one in the general information that we have, as I move up my slide, we get to the diseases that we need to know. We're going to need to know the difference between typhus fever, Rocky Mountain spotted fever, and Q fever. So, having said that, let's figure out how we're going to be able to tell the differences between the two. The first one we have is Rickettsia prowazekii. It causes epidemic typhus. Epidemic typhus. Now, there's another one that we're going to look at that causes endemic typhus. Ooh, starting to get tricky, right? But I'm going to show you the not so scientific way. Okay, so here we go. Let me get my stuff. Dry erase pen. Dry erase board. Okay, so Rickettsia prowazekii. First thing I need to remember is that it causes epidemic typhus. Well, if you look at the species name, what does it end in? Do you see the 2 I's in prowazekii? Well, which of these 2 words has 2 I's in it? Well, if I had to guess, I would think that Rickettsia prowazekii, since it has 2 I's, and so does epidemic, that would be the answer. I know, nothing scientific about it. But when you've got to discern, okay, one causes epidemic typhus, the other is endemic typhus. So epidemic means it's more widespread. Endemic is localized to a particular area. One is as a result of lice, the other one has to be fleas. You need some kind of mechanism by which to help you. So if that works for you, I would suggest that you use it. So, epidemic typhus. And epidemic typhus is transmitted by lice. Think of how quickly lice can multiply and how easily they can be transmitted. It can cause an epidemic. So, Rickettsia prowazekii, indirect biological vector. If it's a biological vector such as lice, then obviously the portal of entry would be through the skin, and it's transmitted from person to person. So Rickettsia prowazekii, epidemic typhus. Well, then that must mean that the next one, Rickettsia typhi, is endemic typhus. Endemic means that obviously it's kind of, just in a general localized area, but endemic only has one eye. I'm looking at the PowerPoint presentation. Typhi only has one eye. So therefore, this particular microorganism causes endemic typhus. Transmitted from, oh, my battery is low. I might have to come back to you in a minute. But it's transmitted, close that, from man by either a flea that has bitten a rat or a mouse. So obviously the portal of entry would be the skin. Okay? Epidemic, endemic. Now let me see if I can discern what the students from a previous semester used. Okay. Oh, one of the characteristics of Rickettsia prowazekii is that it has an outward rash. The rash starts from the outside and it moves inward, or outward spreading. I'm sorry, it spreads from inside to out. So they came up with the fact that in the word prowazekii, you see OW. That OW would indicate that as a result of this particular bite of the lice, right? Yep, of the lice, a rash would develop from the site where the lice bit the person, and it would spread outward. Okay? That's going to be an important fact to know, because there is another one in which the rash starts from the outside and moves in. Okay, so Rickettsia prowazekii, epidemic typhus from the bite of lice. And since it says prow, OW, from the site of the bite, the rash spreads outward, then that means Rickettsia typhi is endemic typhus. Typhi only has one eye, and so does endemic. However, that is transmitted by fleas, but the fleas bit either rats or mice that had that microorganism in it. And then the last one we already know, Rickettsia rickettsii, is caused by the bite of a tick. Remember, the tick must actually bite, bore its head, and feed. And so I thought this one was cute that the class came up with. It's called, they said, Rick the tick. That's how they remember the biological vector. The vector is the tick. So the tick that actually bit the deer, that then landed on the person and would bore its head and feed, causes Rocky Mountain Spotted Fever. Now, this is the disease in which the rash starts from the outside and moves